Okay, good morning, all of you. My screen is visible. Anybody? Prashant, my screen is visible. Okay, we'll see today another algorithm. Last class we discussed the support vector machines. So that is also the classification. There, what we did is there is a classes, two classes there. You need to divide two classes separately. And when new data comes, we need to assign it is belongs to class one or a class two or something like that. Similarly, there is a another classifier. We call it as a Navi bias classifier. So it is used to find again classification problem only. This algorithm is supervised learning algorithm based on a Navi bias theorem used to solve the classification problems. As we know that there is a lot of algorithms are there. One is support vector machine, another one is Navi bias classifier, decision tree, and like that we have some of the methods. And these methods will all will do the classifications as a now. So now in the support vector machine, I mean supervised learning, as you know that classification and regression. Now we are discussing as a classification. In that, this is one of the algorithm. It is used to text the classification that includes the high dimensional training data set as well. It is one of the simplest and most efficient classification algorithm. This Navi bias algorithm is very simple and most efficient algorithm, help to build fast machine learning models that can make quick predictions. So using this, we can able to predict the new data comes. We have to assign it is going for classification, which classification it will be. The probabilistic classifier means that it predict on the basis of the probability of an object. Some popular examples are Navi Bayes algorithm are spam filtration, sentiment analysis, and classifying articles. These are the, some many more is there. Just I'm telling these. Suppose the mail comes, we have to all classification only. Mail comes, it is a spam classic spam related mail or it is a useful mail or something. Sentimental analysis like that. It is going to be divided. And why the name is called as a naive Bayes algorithm? Because this algorithm is comprised of two words. One is naive, another one is Bayes. Naive means it is a because it is assumed that the occurrence of certain features is independent of the occurrence of other features. Suppose the this name itself we are dividing as a naive and bias. So naive means occurrence of certain features is independent of other occurrence features. If the fruit is identified on the basis of color, shape, taste, then the red spherical and sweet fruit is recognized as an apple, and hence each feature individually contribute to identify the apple without depending on each other. So once if we identify based on the feature, the new data comes. If the features are matched, we can easily classify. And bias means it called bias because it depends on the principle of Bayes theorem. There is your total problem is going to solve using Bayes theorem only. Now, Bayes theorem states that the following relations give the class variables y and a dependent feature vector x1 through xn. So here the class variable is a y, and let it be as output. It depends on what features. So like what we discussed in the previous slide, there is a mango and an apple or something based on the color, feature, taste. We divided this fruit is related to so and so. Similarly, Here the output variable is y and dependent features are some variables. That variables x1, x2, x3 and so on up to xn. Based on these variables you are dividing. Now Bayes theorem, this posterior probability P A probability of A with B is equal to probability of A into probability of B with A divided by probability of B. So this the division you can see that posterior probability and prior probability and the likelihood probability and marginal probability. So these are the some terminologies. We can see that same formula. P and means probability of A with B, that we call it as a posterior probability. That means probability of A being true when the A is true given B is true. So that we call it as a posterior probability. And B, a probability of B with A means that is a likelihood. So the probability of B being true given A is true. Whereas similarly, posterior you can see the probability of A being true given B is true. But whereas here likelihood probability of B being true given A is true. And then prior probability. Here the probability of A is being true. This is the knowledge. Whereas marginalization means probability B being true. So these are the some just terminology. Anyhow, only normal formula. It is not a complicated. Simple formula. You have to apply this formula to find classification. For that small mathematical relations, as I said, no, y is a variable. Given class variable is y and dependent feature vector x1 through xn. Similar fashion, you can see this one is a one probability of y output. So if the with the x1, x2 is a features. Similarly, as same fashion, whatever formula it is there, similar manner, you can see the probability of y with these variables with y is true, and then probability of x1 to x3. And you simplify all these things, they make it as these are mathematical relations. And Bayes theorem which used to determine the probability of hypothesis with prior knowledge. It depends on the conditional probability. The formula you can give same formula. Otherwise, the probability of B given A, that means P of B with A, that is nothing but a probability of B with given A, and this is a probability of B, and this one is a probability of B. This is A and this is B. Now we can see the terminologies. Already I mentioned posterior probability means that probability of A with B means that A is true with B is true case of A given B, and probability of hypothesis event A occur given that B has occurred. Like that we mentioned the likelihood probability and then prior probability and then marginal probability. These are the some terminologies, the probability terminologies. Now, in that other variable name also you can mention it. Here Bayes theorem is there is a classification because of provides a way to calculate the posterior probability. You can see here what is the posterior probability. This one we call it as a posterior probability. Same terminology, they may be used H and D something. And the argumented of this. So this formula you can use it, or directly we can able to calculate any instant if new instant comes with the features. Suppose x1, x2, x3 features. In that each instant you can calculate the probability when it is class 1 case, what is the probability, and class 2 case, what is the probability. Based on that, new data is belongs to which probability you are writing. This is the naive Bayes Casper V naive Bayes is equal to argument of probability of P, Vi, it may be any data, and product of this probability. That's what we can use it later. Just this theory part is used for only the Bayes theorem. Using that, we can able to solve. Now we'll start with some example. Consider the following data. Let it be ABC are the features and K is a class. So now suppose A, B like this. The data may be some data, whatever may be data. Let it be this is the A data, and then this is a B data and C data, and correspondingly K. K is your output. So using this A, B data, whatever may be data, I will let you know the data, some data will take it, and correspondingly K may be based on the data. K be treated as a 1, or K may be treated as a 0, or 1, or 1 and 0, something like that. These are the input data, let us assume that. What we want to find by make use of Bayes theorem or Navi-Bayes classifier, if the data is given A is something and B is something and C is something, the question they may ask you, if these are the data points or values, what is the K? Question is what is the K? So here K is either 1 or a 0. So based on the given ABC new data point, we have to conclude our problem. K is related to 0 classifier or K is related to 1 classifier. That we need to identify actually. In that, you can see the problem is given. Suppose A, B, C. Suppose A is 1, B is 0, C is 1, then K is equal to our output or future, whatever final prediction in that relation or a combination, we got it as a K is equal to 1. Similarly, A, B, C all are ones, then K is equal to 1. With some combination they mention. This is the problem only. So far, this is the data. For that, a data set is given. And now the question is classify the test instance whether the instant is either 1 or 0 using Navi-Bayes classifier. This is the new instant comes. As per the available data, as you know all of you, data set, if A is 1, B is 0, C is 1, then our outcome or output or our prediction is 1. Let it be the already labeled data. Output is 1. Like this, with this combination, you have the outputs is like this. Now new combination come into picture. This is our new combination. What is new combination? A is 0, B is 0, but C is 1. Then what is the K? This is the question. For that, you have to use the Naive-Bayes algorithm. So A, B, C values are given, then we can easily find what is the value of K. In that, the problem is very simple. This is up to now, we call it as a given problem. Now what we want to do, whether K is 1, what is the probability of getting K is 1? And what is the probability of getting K is equal to 0? We have to find. For that formula with ABC data is this one. If ABC data is this one, what is the probability of K is 1 or what is the probability of K is equal to 0? Both you can test, both probability you can compare. Which probability is giving more value, that is the K value. Either K is 1 case we are getting more probability or K is 0 case we are getting more probability. Based on that, your outcome K value, you can decide whether it is a 1 or it may be 0. So based on that, we can able to define. In that, you can see first class K is equal to probability of K is equal to 1 with what? A is 0, B is 0, C is equal to 1. For that formula, using Bayes algorithm, you can see probability of K is equal to 1. What is the probability of K is equal to 1? among the given data, we can see that K is 1 is how many? 1, 2, 3. So these are the K is 1 cases, 3 cases are there. Out of only 6 cases. So that means 3 by 6 you can write and multiply, because as per formula, as I mentioned here, you can see Bayes algorithm, this is the product of this. This is the probability of Pj or P of Vi or Vj and product of rest. So as per that formula, we can see here probability of K is equal to 1 into probability of A is equal to 0. This is the combination. You can see that what we are checking is only understand the formula, then remaining is dead easy. Only 1 minute time to solve the problem. K is 1 I taken, first case. Other case K is 0. And with ABC data is this one. And here also ABC data is this one. With this ABC data, K is equal to 1 and K is equal to 0. So if K is equal to 1 case, A is 0, B is 0, C is 1. Similarly, K is equal to 0 case, A is 0, B is 0, C is 0. We are finding the probability with these conditions. Now, here K is equal to 1 and now probability of K is 1 when A is equal to 0 and probability of B is equal to 0 when K with the K is equal to 1 and C is equal to 1, K is equal to 1 case. So with this combination, we need to find the probability. First probability I mentioned P probability at K is equal to 1. So K is equal to 1 means 1, 2, 3. That means 3 by 6. This is the probability. And other one you can see here P, A is equal to 0, K is equal to 1. Now we can see A is equal to 0, but K is equal to 1. How many instants we have? A is equal to 0. But what is K? K is 1 we required, but this is 0. So we cannot take this. And other one, A is equal to 0 and K is 1. This one is suit. Then what is the value among 3? Because K is once or 3 times, no? But here A is equal to 0, K is equal to 1, we occurred only one instant. That is the reason 1 by 3 we consider. See how I am solving simple with the formula and with the data. A is equal to 0 and K is equal to 1. So this instant A is equal to 0 and K is equal to 1, only one instant among 3 instant. Why among 3 instant? K is 1 is occurred 3 times. But in that A is 0 means only one time it is occurred. So that's why 1 by 3. And other one you can see this one. B is equal to 0. You can see here B is equal to 0. Another one is K is equal to 1. How many instant it is occurred? You can see. There is a B is equal to 0. Now B is 0. K is 1. This is one instant. And B is 0, but K is 0. We cannot take. And there is another instant. These are the two instants we have. B is 0 with K is 1. So then our answer is 2 by 3. Out of 3 instances for K is 1, only we have B is 0 cases are 2 with K is 1. Of course, here B is 0 only, but K is not 1. That's why we don't take it this. And this valid, this is 1, this is second one. So 2 by 3 we got it. Another last C is equal to 1 with K is 1. I'm checking. C is equal to 1 with K is 1. Now what is C? This is 1, K is 1, one instant. And there is another instant. And that's it. So there is a 2 instance. We call it as a 2 by 3. Now the probability of getting K is equal to 1 in this data set is 0.07407. This is the 1. Getting K is equal to 1. Same manner you do for k is equal to 0 cases. Now I'm checking with this A is 0, B is 0, C is equal to 1. What is the probability of k to get 0 value? For that case, again same formula. What is formula different? You can see k is equal to 0. Here formula will modify like this. K is equal to 0. Probability of k is equal to 0. And A is 0. Probability of k is 0. Wherever 1 is there, you make it as a 0 k case. And now the formula will be, because anyhow denominator here and here is there. That's why I'm not taking this portion. The numerator is sufficient to compare. Now what I'm doing, k is 0. How many k is zeros? 1, 2, 3 out of 6. So therefore 3 by 6 I wrote. And another one, a is 0 but k is 0. Second formula you can write like this. A is 0, k is 0. So a is 0 and k is 0, 1. And a is 0, k is 1. So only 1 is there. This is a is 0 with k is 0, 1. That means 1 by 3. You make it as a 1 by 3. Total k 0 cases are 3 cases. Among 3 cases, if B is 0 and A is 0 and C is 0, we have to identify. So A is 0 with K is 0 is 1 by 3. And B is 0 with K is equal to 0. B is 0 with K is equal to 0. Yeah, this is one instant. We have, that's it. So therefore it is a 1 by 3. And another instant you can see C is equal to 1, K is equal to 0. C is equal to 1 and K is equal to what we have? We need 0. So this combination how many? That's it. So C is equal to 1. Yeah, this is 1. But K is only 0 case only you have to consider. This is one instant. And there is a 2 instant. That's why 2 by 3 you can write. So you calculated probability of getting classifier of k is 1 and getting classifier of k is equal to 0, and you compare these two and you can decide whether this is going for a class 1 or class 2. Now this is 0.07. This one is how much? 0.07407 is at k is equal to 0 instant. And hence the test example will have a classifier 0.0407 at k is equal to 1 and k is equal to 0 case, you got it 0.03 only. Then which one is more? Probability of getting k is equal to 1 is more. That's why hence your example with the this data will belongs to new data comes, we can classify this into class 1. And another B bit also they asked, find probability k is equal to 0, but only two features are available. Let A is equal to 1, B is equal to 1. Only you can repeat that problem. You can see k is equal to 0 instant and A is equal to 1 and B is equal to 1 with k is equal to 1 notation. We can write the formula with this formula, and from the table you can identify these two combinations. K is 0, A is equal to 1 and B is equal to 1. K is 0, probability of getting k is 0, and what is the A and B? So they are giving what is the value of a is equal to 1, b is equal to 1, and if we substitute this, we got it as a 2 by 3. That is one example. Now read all of you this example and try to understand, then I will explain once again. What we have to do is, there is a data set. So how many data sets? 14 days data set is given. Day 1, what is the climate condition? Then whether we are going for playing tennis or not. With this data condition, past data condition, they have labeled whether you are going for tennis or not, because you are already completed this work with the previous data set. Now the question is new question. Then you have as a data set day 1 to day 14. Let it be day 1. The outlook is sunny and temperature is hot, humidity is high, and then wind speed is weak. But because of the data availability, outlook, temperature, humidity, and wind, the you are not gone for playing a tennis. So this is a no. Then the sunny outlook, temperature is hot, humidity is high, but wind is strong. Then also you are not going for tennis. That is what already past data is available. And then rain, outlook is rain, and then temperature is cool, and then humidity is normal. Then wind is strong. Then also you can say no. But some cases are there if outlook is sunny and temperature is mild and humidity is normal, then wind is strong, then he is going for playing tennis. This is what available data. And from the available data, what we have to do is we need to find what we can do is we need to find the new data comes. So now the question is some after some time, after 1 month, the data point may be like this. Outlook is sunny. Now the outlook may be sunny. Then temperature is cool. Then you can write cool is your temperature. Then humidity is high. Humidity is high. And other one is wind speed is given as a strong. So wind speed is strong. So using this data, we need to predict this class. Only left out is play tennis or not. So based on the data, we need to identify whether you are going to play tennis or not with this condition. This is the present situation in the outlook, temperature, humidity, and wind speed. Now for that, use again same formulas. This is nothing but this formula only. What we are doing here, first whether you are going for tennis or not. How many classes we have? Two classes we have. That's why first find the probability of getting S value with subjected to what? This is the probability of S with subjected to this outlook sunny, temperature is cool. So that is the given data set point, and new data set point. For the new data set point, what is your prediction? Whether go for tennis or not, or yes or no. Now we can see the formula. Uh, Formula is P is yes. Probability of yes going for tennis with condition is what? These are the conditions. New instant condition. Instead of writing all, I mention as a new instant. What is the new instant? I already defined here. New instant. Just a minute. Now we can see here what we are doing is the probability of going for 10 is yes how much and no how much with the new instant. So based on that new instant, we can see here what is the probability. New instant is to be classified. Outlook is sunny, temperature is cool, humidity is high, and wind is strong. So in that case, what is the probability of getting yes and what is the probability of getting no? For that formula, as per this formula, you can see whatever I mentioned S here, probability of S, you can write. And what is other combinations? You can see from the data, other combinations formula, you can easily write outlook is sunny. So that's why probability of sunny is yes. And probability of cool is yes. Probability of high, because the whatever they mention, see that sunny, cool, high, and strong. In this case, it will be yes when it is how many times it is a yes. Even outlook is sunny, what is whether yes or no. And outlook, I mean temperature is cool, then we played tennis or not. How much, how many times it will be yes during these instants. That is the formula. Same formula, but no. See, outlook is sunny, but not played. And temperature is cool, but no, is not play tennis. Like that combinations, this is the formula. If you identify these two probabilities, then we can easily get the value of probability P value, and yes condition what is the probability, no is what is the probability. You compare these two values, which is more, then your answer is, suppose if this value is more, then you can say this is the final answer for the given instant. For the given instant, I can say it is a no if this probability is more, or if this probability is more, then I can say it is a yes. So this is the what we need to do. Now we can see what is the value of this, anybody can say, because probability of getting yes. How many instants out of 14? How many yes you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So your for this value is what is your answer? 9 by 14. This is 9 by 14. Like that, you identify the probability of getting sunny time. How many yes we have? This is sunny. You can see sunny. Yes, both you can see. Here sunny, but it is no. Here sunny, it is no. And again sunny, no. And sunny is yes. This is one instant. And sunny, yes, this is another instant. That's all, 2. So out of how many sunnies we are able to get yes. So that is the probability of this point. Similarly, cool. You can see cool is 1, yes, we can consider. This is no, you can consider this is yes. And cool, this is yes. And that's it. So there is a 3 instants. And similarly, high. So here how many? High and S both must be there. Then high is 1 and with S, and second one, then third one, 3. And other one strong. Wind is strong. And no, weak S, strong no, strong S. He played strong S, strong S. That's all. So now simply we can substitute that probability value and multiply, we'll get the first case output. So now I can see what I'm dividing is play tennis. Yes. So how many times yes? As I mentioned, tennis yes case 1, 2, 3, 4, 5, 6, 7, 8, 9. So out of 14, 9 is there. That's why I made it as a 9 by 14. And probability of tennis is no. How many no's we have? 1, 2, 3, 4, 5. So that's why I made it as a 5 by 14. So this we calculated, this one we calculated, this one we calculated. Then rest points, as I mentioned, no, is simply you can see. Suppose outlook. Whatever features are there, you take it as outlook, temperature, humidity, wind. These are the four features you take. Outlook. When outlook, yes and no. So how will you get the yes and no? What are the instances in Outlook? Sunny is one instant, and overcraft is another instant. Second, rain is third one, and that's it. So these are the three instants you write. First feature is a Outlook and sunny, overcast, uh, this is outlook and rain. So these are the three instant. What is the probability of getting yes and getting no? You can see. Sunny is getting yes. How many instants? Sunny is getting yes. We can see here one, two, two cases only. That's why I made it as a 2 by 9. Why I mentioned 9? This is outlook of, you can see here, outlook of yes. How many yes we have? Only 9 yeses and 5 no's. That's why out of 9, Sunny, outlook is Sunny, but he played. In that instances are only 2. That's the reason 2 by 9 you can write. And overcast, so this is the 4 overcasts are there. Yes, you can see overcast is 1 with yes. This is 1. This is also with yes second and third and fourth. So that's why 4 by 9. And rain with yes. So rain with yes, this is rain 1, 2, 3. These are all can see. Yeah, this is rain, yes. This is not, but it is no. That's why this is 1. And this is 1 second. And rain with s 3. So that's why 3 by 9. So like that, you can fill the table like this. No, sunny in outlook is sunny, but not played 3 times out of 5 times. So that's why 3 by 5. And overcast case, no, because that's why no instant is having, that's why 0. And rain is there, outlook is rain, but he not played 2 times. Out of 5 times, outlook is rain means is not played. That's why 2 by 5. This is the first feature, outlook feature. Similarly, what is the next feature? Take it as a temperature. How many instances? Hot is one instant, mild is another instant, cool is another instant. Like that, 3 instants you can write and make a probability. What is the probability? Humidity, temperature, hot, mild, cool. Cool. In that, how many times yes? How many times? No. From the data set only you can able to calculate, because in this yes case 9 yeses and 5 no's. In that 9, how many times is yes when hot? Temperature is hot. When temperature is mild, how many times yes he played? When temperature is cool, how many times he played? Like that, you can fill this table from the data set. And similarly, no's. How many times it is a no? That is a 2 by 5, and this also 2 by 5. This is a 1 by 5. So like that, we can able to get these all features. One feature is outlook, another feature is the temperature, then humidity, and then windy. So this is the S instant, this is the no instant. Now you can fill the data. So what is this data? Probability of yes. This is a 9 by 14 means 0.64. You can write here, multiply. Sunny, sunny, yes, 2 by 9. I will write here for this case. What you want to do is probability of yes, that is a 9 by 14 multiplied with sunny, yes, 2 by 9. This is all star, not plus. And again, this cool. cool S. So there is a cool S 3 by 9 and multiplied with high. Temporary humidity is high. That is S 3 by 9 and strong 3 by 9. That's it. That is equal to, you got it, point not 53. And no case, same formula, you can use it here, this formula. In no cases, what you can write, this is equal to 5 by 15 and 5 by 14 multiplied with sunny no 3 by 5, then cool no. So cool no 1 by 5, then high no, here high no 4 by 5, and then strong no. This is a strong no 3 by 5. That is equal to 0 0.0. So 0.02. So then which is having more probability? This value is a more. 0.02 is more than 0.005. That's why play tennis chances are less. That's what it is a no. With this instant, if the features are this one new features, then getting chances are for play tennis is no. Similarly, if you want to use a further formula also, you can extend that. Same thing only, whatever we used this naive bias with this formula, we calculated 0.05, 0.05 and 0.02. We got it. This is the naive bias S case, naive bias no case. And you can use further this formula as well. Anyhow, there itself we can conclude if we use this naive bias yes with this formula, you got it 0.2. Now, after calculating this, you will get this 0.79. Then also it will be as a play tennis is no. Either you can stop here itself, you can understand which is having more probability. Same thing will extend if you want to use this formula also, you can use it. But finally, the getting chances are no. This is the way we are able to solve the problem. Now we can see another example. This you have to do by understanding the previous questions. It is very simple. What they are asking, estimate the conditional probabilities of each attribute. What is the attribute? The color is one attribute because that's what attribute or features. How many features is given? These are the four features are given. Color, then legs, height, smell. So based on this species classes, whether you are to find the species is M or a H using the data given in table. So this is the data set is given in a problem. But now what is this? If new instance comes like this, one way we can remember. If sunny temperature is this much, day month is this one, and year is this one, and so and so. The radiation is this one. If solar generation is so and so, like that, you may have the 5 years data or 10 years data set. Then the question may come in 2024 February and 5th. What is your generation? If radiation is this much and these are the features, then what is your probable of solar generation? Like that. So similar manner here also the question is what they mention two things. What is the estimation condition? Color, then color is this one, legs is this many, height is this, smell. These are the features. Now we can see the available data set first. There is a number, 8 instances is given. The first instant color is white, legs are 3, then height is short, then smell, no smell, or S, let it be. Smelly, S, then species is M. Similarly, green, 2 legs, tall, then smelly is no, then also species is young. And like that, if the color is white, legs is two, and then height is tall, and smell is no, then it is a H. If this instance, we can observe there is a M and H for that point of time. The color is green, then legs are two, then height is tall, then smell is no. The question mark is here. You have to find using I bias algorithm. So what is your answer? Either it is a M or a H. That is what we need to find. So how to find whether it is a M or a H? So only thing is, first, if these are the instances, probability of getting yes, or I mean probability of getting M, how much you can calculate with these features, and similarly probability of getting H with these features. What is features here? Green, both cases green, and then legs are two, and then height is tall, then smelly is no. Like this, what is your probability? So in that case, we can easily identify the what is your conditions. So in this condition, we can easily identify answers. Now, first you can see the probability of M and probability of H and vice versa, anything you can do. Now for that, what I'm doing, this is the given data set, 8 instances are given. And what is new instant? New instant color is green, and then length, legs are two, and height is tall, smelly is no. In this, we can see what is probability of M in normally for the given data set, what is the probability of M? 1, 2, 3, 4 out of 8. That means 4 by 8. Another one is H, probability of H. 1, 2, 3, 4. That is also 4 by 8. So now we'll get it as a two things. First PM. Now we'll go for each feature probability S and or here instead of S and no, what is given? M species and H species. So how many times M species when the color is white, and similarly when the color is green, and when the color is, that's it, white and green. Now this table will give a species M probability, species H case probability when the color is white, when the color is green. Now what is that? When the color is white, how many times M is there? Color is white, this is M, and color is white, this is also M. That means 2 by 4. Why 4? Total we have M conditions are 4 only out of 8. That's why 2 times it is occurred. That is the reason 2 by 4. And green cases, these two are green with M. Your species is M. That's why 2 by 4. And now again white with no and green with no. I mean, no means here H, let it be. Green with H and white with H. White and H case, yeah, this is the two instance. White output is H, two instance. And other one, green and H, this is the green. Yeah, here 3 is there. White and H are 3 instances. That's why 3 by 4. You make it as a 3 by 4. And green with H is only 1. That's why 1 by 4. So that is the 3 by 4 and then 1 by 4. So like that, we can easily fill the table. First feature is taken as a, what you call it, as color. Then next feature is legs. This is the legs. And how many legs are different? three legs and two legs. So two and three you can fill here. And the legs are two. How many times it will be become as let it be species is M, and how many times it is a H. So like that you can fill H and M's are the instances. Similarly, we'll go for third one, height. Height, what are the instances here? Short is one instant, tall is another instant. So you make it as a tall and short. When height is tall, species may be young, these three times. And short, this is a one time. Similarly, H cases is this. And finally, smelly. So if the smelly, yes and no, because in this only two categories are there, yes and no. And what is your target output? Let it be either M or a H. So how many times M, how many times H, like that. Now we got the total data. Once if we get the data, simply substitution. So P of M, P of H. So what is P of M formula? P of probability of getting M, and then probability of color is green and leg is 2, because this is the new instant. No, what they asked is new instant is this one. For these cases, you have to identify the probability. And color is green, legs are two, heights tall, and smell is no. In that case, we can easily identify the probability. Now we can mention probability of M with a new instant, and M color is green, legs are two, height is tall, smell is no. And simply you can see this 4 by 8 is 0.8, and color, you can see the color with green, let it be green. And what is the kind species is M. Now 2 by 4. Now we can mention 2 by 4. And other one is what? Legs are 2. With the M case I'm doing M or a H. Next case is H, M case. Legs are 2 with M, that is a 1 by 4. To make it as a 1 by 4. Another instant is a height is, height is tall. Height and tall with species is M, 3 by 4. Then another instant, smell is no. Then you can see smell and no. What is the value? It is a 1 by 4. So you can write 1. So like that, we'll get it as a probability of the species maybe M is a 0.0117. Same you can do it for H case. Then you got it as a 0.04. Then what is the chance of this instant? Your probability of species, your answer is here what you can write, green. Then legs are 2, height is tall, then smelly is no, then your species is H. Why it is H? Because this one will be more chances. That's why hence the new instant belong to species H category. This is the way we have to solve the problem. Now, similarly, I given lot of problems for your practice purpose. In exam, they may give anything. Even general also they may give. You have to understand how to solve the problem using naive Bayes algorithm. In that case, now the see that stolen. The color is red. Type is sports car. Origin is domestic. Then stolen is yes, means output labeled case, and color is red, and type is SUV car, and then origin is imported car, then stolen is no. Like that, we have 10 instances. The question what they're asking to you is the new instant is red car, means now the new case, whether we have to identify whether it is going to stolen or not. Yes or no. That's what output we need. When the condition is red car, the type of car is SUV car, and it is not imported car, it is a domestic car. Then what is your answer? Yes or no? This is what our question. Now, if possible, all of you can do it. What you will do is first formulas are as usual. What is your probability of getting yes? This is the yes with what is these instances? With the red car, SUV car, and then domestic type, then what is your probability? What is the formula now? P of S. This you can write P of S multiplied with the P of red with S and SUV with S, domestic with S. That you can multiply all the cases. You will get the probability. And another case, P of no, here will be as a no. Probability of no with what is the with red color and SUV domestic type, that is equal to probability of no into multiplied with what? Probability of red color with no and probability of SUV color, I mean SUV model with no into probability of domestic type with no. What is this? This if we multiply and compare these two, we can easily calculate. First, probability of getting S cases how many? 1, 2, 3, 4, 5. That is a 5 by 10. S case 5 by 10. No case also 5 by 10. So you'll get it as a S case 5 by 10. No case 5 by 10. And you can see the problem. Simple steps. Nothing is there. Same problem. I'm changing the data. That's it. The procedure, everything is. What they will give is first they will give the data set. Then they will give the new instant and ask you to find whether the outcome based on these classes. So what maybe classes are different. In this case, S and no. Previously, M and H. Whatever may be the output. So now we can see first probability of S 5 by 10. Then probability of no also 5 by 10. So you will get this first. Then what is next step after knowing that? You take it as a features. Color is one table, type is another table, origin is another table. Now color. In that S and no. Color S and no you have to identify for these cases. What is the instant? If red, how many times it will be yes? Yellow, how many times it will be yes? So similarly, red, how many times no? Yellow, how many times no? That's why color feature yes or no you have to identify, because the targeted you have to write here target case. Either it is yes and no or 0 and 1 or A and B or anything. And what are the instances available? Features red color one, yellow color. You write red and yellow. Similarly, second type. How many categories they given data set? In this small problem, if it is a bigger problem, types may be any still more. You can write that table also, more number of rows and columns. Even if the targeted also instead of yes and no, some cases not applicable or something, anything, whatever feature is there, you can add that also. In that, you can easily identify the answer. So now we can see like that you have to fill and use the formula, and you got 0.02. In this case is 0.07. Then probability of this type of car is stolen yes or no means it is a no. The reason probability is very less in the no case, 0.07 more, when 0.07 probability is more in the getting no. That's why I mentioned no here. But whereas here probability is very less, stolen yes condition. So that's the reason we make it as a no. Like that, I have given even 9 problems or say 8 problems or something. You can able to solve your problems based on this cases only. Like that, any problems also, any number of problems also, you can able to solve. If you have any doubt, you can ask me. I will give, anyhow, I will share this PPT to all of you for further problems also like this. I have given many number of problems. So, example plus and minus, whatever may be the instant. This is the features ABC and class is plus or minus. For new instant is given something like this or anything new instant, They may ask you to find whether class is positive class or a negative class. Again, the outcome is what? Based on the positive or a negative, getting zeros and getting ones. You can divide the probability and compare the data. If the data is which one probability is more, here it is showing 0.008. Here it is showing 0. So that's why the 0.098 is the more. That's why the class is a positive. Like that. I have given many number of problems as well. You can practice it later also. If you have any doubt, you can ask me. Otherwise, you can leave.
Excuse me, sir.
Yeah, tell me more.
Where are you, sir? I want to meet you once. I'm in the college.
Yeah, I'm in my cabin, HOD cabin.
Okay, sir.
Okay.
Can I meet now, sir?
Yeah, you can come.
Okay, sir.